So here's example 17.14 from the book. This is an example when you don't know whether or not the wheel is slipping or not. So the wheel is 50 pounds. It has a radius of gyration of 0.7 feet. There's a 35 foot-pound moment applied to the wheel. Determine the acceleration of the mass center, g. The coefficient of static and kinetic frictions are 0.3 and 0.25 respectively. So the first thing we do is we solve for the mass moment of inertia about the point g. It's equal to the mass times k squared. So you can see that here. Here's the mass times k squared. So the moment of inertia about g is 0.7609 slug feet squared. So the next step is to draw the free body diagram and establish the coordinate frame, which you see here. Now, since I don't know if the wheel is slipping or not, I'm going to follow my procedure outlined earlier in this lecture. So my first step is to assume that the wheel rolls without slip, so I have some frictional force here, and the acceleration of the mass center is going to be equal to r times alpha. But here's the equations of motion. So summation of forces in the x is equal to the mass times the acceleration of the mass center in the x. So F sub a is equal to the mass times the acceleration of the mass center. In the y direction, I get n minus 50 is equal to 0. So now I know the normal force is 50 pounds. And I sum moments about g and set that equal to ig alpha. So we have an applied moment of 35 foot-pounds, and he's assuming positive direction clockwise, minus this 1.25 times the frictional force is equal to the mass times alpha. We have 4 unknowns and 3 equations, so we need another equation. So we're making the no-slip assumption first. We're going to assume that the acceleration of the mass center is the radius 1.25 feet times alpha. So you can solve those equations 1 through 4 and come up with these numbers right here. Now you need to make the check. Is the frictional force that I calculated in a no-slip condition less than or equal to the static coefficient of friction times Na? However, in this case, 21.3 pounds, which is the frictional force we found, is greater than u sub k times the normal force. So the wheel does slip. So this solution up here is incorrect. Now you can assume that the wheel is slipping. So the frictional force now is the kinetic coefficient of friction times the normal force. And you use this equation to solve the problem with the first 3 equations. And you come up with this answer right here.